Welcome to the fascinating world of quantum mechanics, the branch of physics that takes us into the smallest scales of the universe. Here we dive into a realm where the ordinary rules of physics bend and twist, giving way to a world that seems almost magical in its strangeness. But don't be fooled by its peculiarity, for this is the very foundation of our universe. Quantum mechanics, in essence, is the study of the behavior and properties of particles at their most basic level. We're talking about the minuscule world of atoms and subatomic particles, the protons, neutrons, and electrons that build up everything we know. If you've ever wondered why the sky is blue or why diamond is harder than graphite, you're essentially asking a quantum question. But quantum mechanics isn't just about understanding the universe at the atomic level. It has a vast range of applications in various fields that have an immense impact on our daily lives. From the technology we use, the medicines we take, to the security of our online information, it's all deeply rooted in quantum mechanics. Take quantum chemistry, for instance. It's the study of how atoms and molecules interact and form bonds using quantum principles. It helps us understand the structure and properties of matter, like the color, reactivity, and stability of substances. Then there's quantum optics, dealing with how light and matter interact. This field has given us fantastic technologies like lasers, LEDs, and optical fibers, and let's not forget quantum computing. By using quantum bits or qubits, it can help us solve complex problems that are beyond the reach of classical computers. Think cryptography, optimization, and simulation. That's the power of quantum computing. Lastly, there's quantum metrology, using quantum principles to measure physical quantities with higher precision and accuracy. Time, length, mass, all can be measured more accurately using quantum phenomena like entanglement and superposition. So, quantum mechanics is our key to unlock the secrets of the microscopic world. It's the miniature universe that holds the answers to the grand questions of existence and the fabric of reality itself. Quantum chemistry, a field that explores how atoms and molecules interact and form bonds. This fascinating realm of science dives deep into the microcosm of matter, taking us to a universe that is as bewildering as it is fundamental. In the simplest terms, quantum chemistry is the application of quantum mechanics to chemical systems. It allows us to delve into the intricacies of atoms and molecules, deciphering the rules that govern their behavior. But why is this important? Well, it's because the properties of every substance around us, from the air we breathe to the screen you're looking at, are determined by the interactions and bonds formed by these tiny particles. Imagine you're looking at a stunning sunset, a riot of reds, oranges, and purples streaking across the sky. What gives the sky its breathtaking hues? Quantum chemistry holds the answer. It tells us that the color of an object is determined by how its atoms and molecules absorb, reflect, and emit light. Furthermore, it explains why certain substances are reactive, readily engaging in chemical reactions, while others remain stable and inert. Let's take a moment to appreciate the paradox of stability and reactivity. Some substances, like noble gases, are known for their lack of reactivity. They're content to exist in their current state and rarely participate in chemical reactions. On the other hand, some elements are highly reactive, like oxygen, which readily combines with other elements to form compounds. It's the principles of quantum chemistry that explain these differences in reactivity. And not to forget, the stability of substances, which is a crucial factor in everything from the preservation of food to the storage of nuclear waste, is also encompassed by quantum chemistry. It can predict how long a substance will remain stable under different conditions, providing invaluable knowledge for a multitude of industries. By examining the building blocks of matter through the lens of quantum chemistry, we gain a deeper understanding of the world around us. It's like peering into the heart of matter itself, witnessing the interactions and transformations that shape our universe. Thus, quantum chemistry forms the foundation of our understanding of matter. It's a testament to the power of human curiosity and the endless quest for knowledge, allowing us to comprehend and manipulate the world on a truly microscopic scale. Moving on, we have quantum optics, the study of interaction between light and matter. This might sound quite complex, but in essence, it's all about the dance between light particles, known as photons, and matter. Imagine a grand ballroom, where photons are the dancers and matter the dance floor. The photons pirouette, twist, and twirl, interacting with the dance floor in a myriad of ways. This is exactly what happens in the quantum world, but instead of a dance floor, we have atoms and molecules. And instead of dancers, we have photons. But why is this dance so important? Well, it's because it gives us the ability to create and manipulate light sources such as lasers, LEDs, and optical fibers. Lasers, for instance, are a perfect example of quantum optics at work. They operate based on the principle of stimulated emission, where a photon interacts with an excited atom, causing it to emit another photon of the same frequency, phase, polarization, and direction. This leads to an intense, focused beam of light that we know as a laser. Then we have light-emitting diodes, or LEDs. These devices emit light when an electric current passes through them. The color of the light depends on the type of semiconductor material used, a phenomenon that can be explained using quantum principles. And let's not forget optical fibers. These are strands of glass or plastic, thinner than a human hair, that guide light from one end to the other. Quantum optics allows us to understand how light can be guided in this way, leading to the development of high-speed, high-capacity communication networks. Quantum optics is not just about understanding how light and matter interact. It also provides us with the tools to manipulate this interaction, creating technologies that have revolutionized our world. Quantum optics indeed illuminates our understanding of light and matter interaction. Now, let's delve into quantum computing, where quantum principles perform computations. In the realm of quantum mechanics, we encounter a fresh breed of computing, quantum computing. This is no ordinary computing, mind you. It's a whole new ballgame. Quantum computing harnesses the peculiar properties of quantum physics to process information in ways that classical computers simply can't match. You see, while classical computers use bits, those familiar ones and zeros, to handle information, quantum computers use quantum bits or qubits. Unlike a classical bit that can be either a 1 or a 0, a qubit can be both at the same time, thanks to a quantum quirk known as superposition. This allows quantum computers to process a vast number of possibilities all at once. But it doesn't stop there. Quantum computers also utilize another quantum phenomenon known as entanglement, where the state of one qubit becomes intertwined with the state of another, no matter the distance between them. This entanglement facilitates intricate computations with a speed and complexity that are simply beyond the reach of classical computers. So, where could this lead us? Quantum computing has the potential to revolutionize areas like cryptography, optimization, and simulation. It could crack codes that would take classical computers millennia to decipher. It could optimize complex systems from global supply chains to molecular structures in ways we can barely imagine. And it could simulate quantum systems like complex chemical reactions or even entire universes, providing insights into the very fabric of reality. But let's not get ahead of ourselves. Quantum computing is still in its infancy, with many technical challenges to overcome. Yet, the potential is there, waiting to be unlocked. Quantum computing thus holds the promise of a computational revolution. Finally, we have quantum metrology, using quantum principles for measuring physical quantities. Now you might be wondering, what's so special about this? Well, the answer lies in the unique properties of quantum mechanics, entanglement and superposition. Let's start with superposition. In the quantum world, particles can exist in multiple states at once. That's a bit like being in several places at the same time. Imagine if you could be at home, at the office, and on a beach vacation all at once. That's superposition for you. Now, this peculiar trait gives us the ability to measure quantities with a precision that is simply unattainable by classical methods. Next up is entanglement, a phenomenon where particles become interconnected, so much so that the state of one particle instantly influences the state of another, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, enables us to correlate measurements between entangled particles, further enhancing the precision of our measurements. But why do we need such precision? Well, in many fields, from navigation to healthcare, precision matters. For instance, in GPS systems, even a tiny error in time measurement can translate into a significant positional error. In medical imaging, higher precision can help identify diseases at an earlier stage, potentially saving lives. Quantum metrology also holds promise in the field of fundamental physics. It can help us test the limits of quantum mechanics and potentially uncover new physics. For example, it could help us detect gravitational waves or dark matter, two of the most elusive entities in the universe. So, you see, quantum metrology is not just about measuring things. It's about pushing the boundaries of what we can measure and how precisely we can measure it. It's about harnessing the weird and wonderful properties of the quantum world to gain deeper insights into our universe. Quantum metrology, therefore, is the future of precise measurements. So that was a quick journey into the mesmerizing world of quantum mechanics. We've delved into the miniature universe, a realm where the laws of physics, as we know them, are rewritten. We've explored the quantum building blocks of matter, the atoms and molecules that form everything around us, and how they interact and bond. This field, known as quantum chemistry, helps us understand the structure and properties of matter, such as the color, reactivity, and stability of substances. We've danced with light and matter, exploring the field of quantum optics, the study of their interaction. This understanding allows us to create and manipulate light sources, from lasers and LEDs to optical fibers, further expanding our capabilities. We've pushed beyond the classical limits with the power of quantum computing. Using quantum bits or qubits, we can perform computations that are far beyond the reach of classical computers. This opens up a new world of possibilities for solving complex problems, such as cryptography, optimization, and simulation. Finally, we've measured the immeasurable with quantum metrology. Using quantum principles, we can measure physical quantities like time, length, and mass, with a precision and accuracy that was previously unattainable. This is made possible by quantum phenomena such as entanglement and superposition. Our journey into the world of quantum mechanics has only just begun. The fascinating principles and applications we've explored today are just the tip of the iceberg. Quantum mechanics continues to unfold itself, revealing new mysteries and solutions every day. Remember, the quantum world is not just about understanding the universe at its smallest scales. It's also about harnessing this knowledge to make breakthroughs in various fields, from chemistry and optics to computing and metrology. Quantum mechanics is a fascinating field full of potential and promise. It's a world where anything is possible, where we can dream big even while we study the smallest of things. Thank you for watching. Please subscribe for more videos like this one.